Is there life in the universe apart from Earth? In this video, we will introduce you to some planets outside the solar system where life could be conceivable. Regarding the question of whether there is life in our solar system apart from Earth, we would like to refer you to our earlier video, which we have linked for you in the video description. Life outside the solar system is particularly conceivable on exoplanets. Exoplanets are planets that are located outside our solar system. To date, the discovery of just under 7,000 such exoplanets has been confirmed. However, there are most probably billions of them in the Milky Way alone. An exoplanet alone is by no means confirmation that it is suitable for life as we know it. For this, it must fulfill additional requirements, namely be at the right distance from the associated star, contain water, have a suitable atmospheric density, and keep away deadly radiation. There are also other geophysical and geodynamic aspects. The first planet to be introduced is Kepler 186f. Kepler 186f is located in the habitable zone, but whether it is actually habitable depends on its atmosphere, which is as yet unknown. Due to the great distance, this cannot be analyzed by current or future telescopes such as the James Webb Space Telescope. A climate model suggests that the surface temperature would be above 0 degrees Celsius if 0.5 to 5 bar CO2 is present in the atmosphere. The Kepler 186 system is probably older than a few billion years, probably around 4 billion years. There is a 50% chance that Kepler 186f rotates bound, which means that its day may last weeks or months. The planet's low axial tilt means that there are no seasonal variations like on Earth. Its near-circular orbit also prevents seasonal changes like those that occur on Mars. A 2015 analysis concluded that Kepler 186f, along with Kepler 442b and Kepler 62f, are the best candidates for potentially habitable planets. Kepler 442b. Kepler 442b is an exoplanet that stands out due to its potential habitability. It orbits within the habitable zone of its host star, a region where liquid water could exist on its surface. This planet is notable for its Earth-like size and temperature, making it a prime candidate in the search for habitable worlds beyond our solar system. Kepler 442b orbits a K-type main sequence star, which is smaller and has a longer lifespan than the Sun, remaining on the main sequence for 18 to 34 billion years compared to the Sun's estimated 10 billion years. Although smaller stars like K-type and M-type stars exhibit high stellar activity early in their lives, emitting strong solar winds that can be detrimental to life, Kepler 442's age suggests it may have moved past this active stage, increasing the planet's potential for habitability. In a 2015 study, Kepler 442b scored highly on a habitability index, which was developed that year. This index suggests Kepler 442b could be more conducive to life than an Earth twin, with similar physical and orbital parameters. However, it's essential to note that this rating does not guarantee Kepler 442b's habitability, as the planet's atmosphere and surface conditions remain unknown. Kepler 62f. Kepler 62f is a potentially habitable exoplanet located in the habitable zone of its star system. It is estimated to be 3 to 11 billion years old. With a radius of 1.46 times that of Earth, it likely has a rocky composition with a substantial amount of water, potentially making it an ocean-covered world. If its density matches Earth's, its mass would range 2 times that of Earth. Kepler 62f's climate could vary significantly, potentially being entirely ice-covered without sufficient atmospheric CO2. Simulations suggest various atmospheric compositions and thicknesses could allow for habitable conditions, including Earth-like climates. Its position as the outermost planet in its system means it is less affected by tidal forces, likely maintaining a stable axial tilt and rotational period similar to Earth's. The host star, a K-type main sequence star, offers a benign radiation environment due to its low stellar activity and long lifespan of 20 to 40 billion years. This stability enhances Kepler 62f's potential for habitability. Highlighted in a 2015 review, Kepler 62f remains a compelling candidate for further study regarding its atmospheric and surface conditions to confirm its habitability potential. TRAPPIST-1e. TRAPPIST-1e is an exoplanet orbiting within the habitable zone of its parent star. TRAPPIST-1, a red ultracool dwarf with only about 8% of the Sun's mass. This star type can remain stable for up to 12 trillion years, making TRAPPIST-1 one of the longest-lived stars in the universe. TRAPPIST-1e is likely a rocky planet. Despite being tidally locked, with one hemisphere permanently facing the star, it is considered one of the most Earth-like exoplanets. It has 91% of Earth's radius, 77% of its mass, 102.4% of its density, and 93% of its surface gravity, confirming it as a terrestrial planet with a solid, rocky surface. The planet is cool enough for liquid water to exist on its surface, but not so cold that it would freeze, like on other planets in the TRAPPIST system. Additionally, models by the University of Washington suggest that its atmosphere is not dense or thick enough to hinder habitability and may help transfer heat to the planet's dark side, further supporting the potential for liquid water and habitable conditions.